equals sine cubed x. And another way to look at this is sine x cubed.
Who wants the derivative of it?
Yes, derivative of these, sorry. Find the derivative. So this will be a power rule followed by a chain rule.
Okay.
So how comfortable are you with this, I don't know, synthesis? Like, can we just do it, or do you like to make substitutions before you do it?
What do you mean by substitutions? Like the u and the v thing?
Like some students are like, I want to make this u equals sine x, so this is really u cubed.
No, I don't really like doing that.
Okay. All right. So the power rule, you just bring the 3 down. So
Right.
y prime is 3 sine x 3 minus 1 squared 2. And then you have to take the derivative of the inside function. Derivative of the inside function is
cosine
x. And then maybe your instructor talked to you about this or not. You can certainly clean this up if you want. It's up to you.
3 sine squared x. Okay. So the chain rule part is just the
cosine x.
Cosine. Okay.
Yes. Any, do you want one like that? Do you want to just keep going?
Yeah, I'll show one like it maybe.
Okay. So an example here, these are really easy to make. It's cosine to the 4th x.
Okay. So it'd be 4 cosine x cubed. Oh, do you put the cubed before the x?
It's generally like when you simplify, you generally put it like before the x.
Okay.
That's just the
preference. And then negative sine x.
Sine x, yeah. Okay, good. All right, number 11 is next. Snip that in. Okay, so again, same instructions, take the derivative. What I see here, and this is what I hope you will see when you're working through this as a review, is that this is a product rule.
Right, because multiplication.
And you know, u and v if you need it.
So it'd be 2x times.
Yeah. So you're taking the derivative of the first. That's what I just heard. 2x
times cosecant 5x
plus
so it's the derivative of cosecant, right?
Yeah.
I need to learn that.
Yeah, take a look at that.
Do
you have a reference sheet that you use, or do you get it from the book?
I need to just get it out. We don't get a reference sheet, so I need to memorize these. But
yes, it's
so it's
it's similar to secant in that it has itself in the derivative.
Is it? Oh, I found it. It's negative cosecant x cotangent x.
Right, but instead of x, what will you put here?
5x.
5x. Okay, and then that's just part of it, though. That there's a chain rule here too. So you have to multiply by 5 for the inside function.
Oh, okay.
That's the chain rule part. And then you have to make sure you don't forget to keep that that x squared.
Right. So it's 2x. Okay,
Okay,
Well-
go ahead.
would you not like the plus minus? Wouldn't you just change that to a minus?
You could, like, if your instructor says simplify, or if it, usually they say do not simplify.
Oh, okay.
If that's the case, then you're done. If they don't say this, then yeah, you want to actually write it as 2x cosecant 5x minus, and then 5x squared would come out front, cosecant 5x cotangent 5x.
Okay.
Okay, now one for you to try. Let's say y equals x cubed secant 3x.
All right. So 3. So is it 3x secant 3x?
3x squared.
Oh,
Secant.
do that.
Yep. 3x.
Secant 3x minus. Oh. Plus.
It's plus, and then derivative secant is secant
Secant 3.
and
3x tangent 3x times 3, right?
times x cubed.
Oh. Wait, would it be,
Because you have to keep the first.
so then why the 3 too?
The 3 is the chain rule derivative of secant. It's the
And then-
derivative.
Oh, x, that's for the product rule, the x cubed.
Yes,
I see.
yes.
Okay, got it. Forgot about that part. Okay.
Okay, let's move on to number 15. Okay. This is I call this what do I call this? E is a function. So you have to know the derivative of that. It's kind of like a sine, a cosine, one of those. And then there's a chain rule part as well.
Okay.
So the derivative of E is always itself. D dx, e to the x equals e to the x. So it's e to the 1 plus natural log of x.
Okay.
But then, and then the next part's on the line with the e. You have to take the derivative of 1 plus natural log of x. So the derivative of a constant is 0
Zero.
plus derivative of natural log of x is 1 over x.
Oh. And then you have to do the, oh, there's no product rule, so it's just chain rule.
Yeah, so then you could, like, this 0 doesn't add anything to it, so it's e 1 plus natural log of x all over x.
Okay.
Okay, so let's try at least one, maybe two like this. So let's say y equals e 1 plus sine x.
Okay, so it'd be e to the 1 plus sine x times 0 plus cosine x.
I didn't catch all that. So it's e to the 1 plus sine x times
0 plus cosine x.
yes. And then what would that simplify to?
E to the 1 plus sine x over cosine x.
No, I'm sorry, I was about that. It's on the same line. So you might even put the cosine x first. but it's in line with the E, so it's on the same level here.
So just cosine x e to the 1 plus sine x.
Yes.
Okay.
Like this. Okay, now let's try one more because maybe there's so we have y equals e x squared plus e to the x. You want to take a derivative of this.
That's 2. E to the x squared plus ex times 2x plus ex.
Yes, times 2x plus e to the x. Yeah, good.
And can you just read it like that?
Yes.
Okay.
I mean, there's a few things you could do to simplify, but I think that's probably good.
Okay.
Okay, so 35, still finding derivatives. Okay, 35 is the first implicit derivative. A lot of students find this challenging. Have we done implicit derivatives before together?
I don't think so.
Okay, I'm going to rewrite this because when we do it in this way, it'll maybe make it more sense. You don't normally need to do this, but it'll help with what I'm trying to show you. So when you're taking a derivative implicitly, x you just treat the same. So what is the derivative of 2x?
2.
Good. Now the derivative of y.
So it would be 3y times y prime. No, 3 times y prime, right?
Yes, y prime. That's right. So it's the same as x, except you always include a y prime.
Right.
Okay. Now this is where most students struggle.
So x would just be 0, right?
Well, the derivative, it's product rule. So it's derivative of x is 1.
Oh, yeah.
And then you keep y plus the derivative of y is
Y prime
y prime times
times
x
x
equals what's the derivative of constant?
0.
0. So this next part, I call it move, factor, and divide. So you move all the y prime terms to one side and all the non-y prime terms to the other side.
Okay, so 3y prime plus y prime x.
So like I would say keep the y primes on the left, and then you subtract 2, and you subtract the y.
Right.
Okay.
And then
so
you take out the y prime. I remember this. Okay.
Factor y prime out. Yep. 3 plus x.
And then you divide by the 3 plus x.
Yes.
So it's y prime equals -2 minus y over 3 plus y.
3 plus x.
Yeah, that's what.
Okay. Okay. As long as you wrote the right thing. Okay. So we should do at least one more of those. The product rule is what I think most students struggle with here. So I'll make sure to include that in a couple of these. So let's say it's 3x squared plus y cubed plus 2xy equals 4.
Okay.
So give that a try. Just the first line, and then I'd like to check with you.
Okay.
I'll be right back, 30 seconds.
Okay.
Okay, how are you doing on this?
So, okay, I'm kind of confused. So it's 6x plus 3y prime.
Squared.
Oh yeah, 3y squared times y prime plus
Yes.
2x times y prime.
So do you keep do you think of it as 2x times y or 2 times xy
Oh, I
or
thought of
something
it as
else?
2x times y.
Okay, so it's product rule again. So yeah, it's 2x y prime
And
plus,
then plus y times 2.
yes, equals 0.
Oh, okay, I got it right. So wait, is there a difference if you think of it as 2 times?
No,
Actual?
well, it if you think of it as 2 times xy, it's 2 times y prime.
Oh, you're just taking the 2 out. I see.
Yes. Wait a second here. This isn't, there's something not right. First times root of the second plus the second times root of the first. Oh, yeah, okay. I see. Yeah, okay. Yeah, so you have to move the 6x over, move the 2y over. That's not all that important. What's important again is that you understand. So let's do one more.
Should I finish this one or no?
No.
Okay.
Let me get to the part that's important. So let's say it's minus xy plus y squared equals 2y. Okay, so this one's more important. And because the product rule here has that negative in front, what I recommend is treating it like it's in parentheses, so you negate both terms at the end.
Okay.
Give that a try, please.
Okay.
Okay, so the first one here is 2x minus, okay, and a couple ways to do this, x y prime, okay, plus y plus 2y y prime equals 2y prime.
Yeah, you got it. Okay. And then
Got it
you
all?
distribute the negative.
Yes. All right, so got that down. We should definitely do those again, or like, yeah, the ones that you just were asked to do are the most common. But okay, so we'd have to do 39. Ugh, these are horrible. Lots of writing. Lots of writing. Okay. Okay. So yet again, you've got to do the implicit derivative here. So it's 3x squared plus 3y squared y prime equals 0. Let me know if that's clear. If that's okay.
3x squared plus 3. Yeah, makes sense.
So normally you would solve for y prime, and you will. Like over here, you're gonna solve for y prime, but over here on the left, you're going to take another derivative.
Okay.
Take another derivative.
Wait, so is it asking for the second derivative or
It
something?
is. Yeah, I'm sorry.
Okay.
I should have mentioned that. Yes, you're taking another derivative because you're trying to find the second derivative. So you continue, like 3x squared is 6x
Right.
plus this is product rule.
Oh, okay.
So I think the way we've been doing it is keep the first,
Yeah.
take the derivative of the second, so that's y double prime, plus derivative of the first, 6y y prime times the second, which is y prime,
Equals 0.
equals 0. Okay, so the reason you solve for y prime over here from this line is because you're going to substitute it back in over here on the left. So y prime over here on the left, 3y squared y prime equals minus 3x squared. Divide both sides by 3y squared. You get y prime equals minus x squared over y squared.
Why do you have to plug in the y squared?
Y prime, you mean?
Yeah.
Because it's like it's accepted that you don't leave it in terms of y prime.
Oh, okay.
So on the left here, slight rewrite. It's y prime squared equals 0 here. Then you have your choice. You can either plug it in now, or you can solve for y double prime and then substitute in.
Okay. What's easier to solve for y double prime?
They're about the same. Like you
Okay.
don't gain much doing it either way.
Let's solve for y double prime and then substitute it, I think.
So yeah, let's solve for y double prime. I think you just heard that.
Okay.
Y double prime equals minus 6x minus 6y y prime squared over 3y squared.
Okay, and then, so then it's like negative 6x minus 6y times negative x squared over y squared squared?
Yeah, you got a lot going on here. So it's this is where you almost want to ask your instructor, hey, do I have to simplify or not? Because here you're squaring that over 3y squared.
Okay, so then it's negative 6x.
So I might leave it like this. I mean, you can do more, but
Oh, really? Okay.
well, it's so what can you do? It's minus 6y
Can you
x to the
distribute?
fourth
Yeah, the
over y
two.
to the fourth. So one of those y's cancel it down, so you get 3 over 3y squared. So a lot of rewriting here. Minus 6y minus 6x to the fourth over y cubed all over 3y squared. Okay, so you can multiply the top and bottom by 1 over 3y squared.
Okay.
So you have minus 6x over 3y squared.
Do they want it in the most simplified form?
That's where you got to ask your instructor.
Okay.
I don't know. So this is minus 6x to the fourth over 3y to the fifth. And you can see the threes cancel. You get minus 2x over y squared minus 2x to the fourth over y to the fifth.
Okay. That is a lot of writing.
Yes, it is. And they only get more complicated.
Oh, yikes. Okay. So I'll ask him tomorrow if he wants how simplified he wants them.
Yeah. So maybe like, like that's a good example. I don't know if you'll be asked to do that on the exam, but we can do another one. I just make it less complicated.
What is this called? This is just like finding second derivatives?
Second derivatives, yeah. Implicit second derivatives.
Implicit second derivatives. Okay.
Okay. So 47. 47 here. Okay, so we have to do another implicit derivative. This one is finding the tangent line and the normal line, which are they're really not that much difference. They're one number different when you're all done. So
it's
some
two. Oh wait, why do you have to plug in? Did the last one have a point that it was supposed to plug in?
no, so sometimes they only give you like x equals 1, and to find y, you have to put the other number in. So here they're telling you though x is 1, y is 2. So you have to first take the derivative.
Okay.
You have to solve for y prime, and then you have to evaluate at 1, 2 to get the slope. So go ahead and find the implicit derivative. Let me know when you're done, and then I'll work through it real quick.
Okay. Was it just 2x plus 4y prime equals 0?
Yes, that sounded correct. 2x plus 4y, y prime equals 0.
Yep.
So y prime equals minus 2x over 4y. And the general rule is like you would only simplify if you're going to use it. So since we are going to evaluate the derivative, you might want to simplify.
Okay.
Doesn't gain you much here, but in other problems it can.
So now you're going to plug in the point.
Yes, so it's -1 over 2 times 2. So -1/4. So that's your slope.
Okay. Is that what that's all it's asking?
No. You have to write the equation line. So it's y minus y1 equals slope x minus x1.
Oh, but you just use the point. So it's
That's
y
part.
minus.
Yeah, that's part A.
So y minus 1 equal, or no, my y plus 1 equals -1/4. Or no, it's y minus 1, right? Because
yeah, it's y minus 2. That's x and y equals -1/4 x minus 1.
Yeah, okay.
Is that okay? Is that clear?
Yeah.
Okay. All right. So do you want to do one like this? Oh no, I'm sorry. Part B. There's part B. Part B is the normal.
Yeah. So isn't there like normal and tangent?
Yeah. So the next is the normal. So the normal line is going to give you a new slope. That's all you're trying to figure out, your new slope. So it's the flip and then the negative of it.
So just 4.
So just 4.
So then you use the same point, right? So it's
Yes.
y
So
minus 2 equals 4x minus 1.
exactly.
Okay.
Right.
Wait, is the tangent the one that we did in A?
Yes.
Okay. And so just those two parts.
That's it. So let me look at the picture on the book again and see if there's another one that's kind of easy to do. Maybe I can just make one up here. Yeah, let's do another one here because I think this is important to be able to do. So let's say 2x plus 3y plus xy equals, let me get you that number. So let's say x is 1. So let's see, that would be 2. 5y equals 5. Okay. So let's say I want the same thing here. I want the tangent and the normal.
Okay.
Okay. But I only tell you that x equals 1. So how do you find y if I just give you the x value?
Elimination.
Yeah, you're gonna put that number in. So it's 2 times 1 plus 3y plus, I messed up this number again. 6 plus 1y equals 6. So 2 plus 4y equals 6. So 4y equals 4, y equals 1.
And then now you can find the slope or whatever.
Now you have to take the derivative. So I want you to take the derivative of this. It's got a product rule in it. And then let me know when you got that, and I'll check how you're doing on that one.
Okay.
Okay, so do you have your derivative there?
Yeah, I got 2 plus 3y prime plus xy prime plus y equals 0.
Good. Okay, and then you solve for y prime. So y prime equals -2 minus y over x plus 3.
Wait, you just like moved to.
Yeah, you move the -2 and the minus y over.
Yeah, okay.
Yeah, so make sure that's clear, and then we'll substitute the value.
Yeah, I just needed to do the extra step there. Okay. So then it's y equals -2 minus 1, 1 plus, it was 1, right? Yeah. 1,
Yes, both
3,
1.
and so then that's -3 over 4. And then you
And
do this.
-2 minus 1 over 1 plus 3, -3 over 4.
Then it's y minus 1 equals -3/4 x minus 1. So that's your tangent. Then the normal is y minus 1 4/3 x minus 1, right?
Yeah, and then it's 4/3. So it's y minus 1 equals 4/3 x minus 1.
Okay, that makes sense.
Yeah. Okay, so now it kind of similar 49. The instructions here, I gotta remember to copy the instructions in. So tangent line again on these, but they're giving they're giving you parametric equations. So it says find an equation of the tangent line. Great. The given value of t. So actually, this is actually somewhat similar to what we just did. They give you t, but you need an x and a y. So you get x from this equation. So x is 2 sine 3 pi over 4. So you got to know your unit circle.
Oh, Lord.
Yeah. So sine 3 pi over 4 minus square root 2 over 2. I'm sorry, it's square root 2 over 2. So that's just square root of 2. And then y is 2 cosine 3 pi over 4. That one is -2 times negative square root of 2 over 2. Negative square root of 2. So that gives you your x and your y.
Okay.
Okay, now y prime is dy dt over dx dt. So you have to take the derivative of this one, 2 cosine t, and then the derivative of sine t here.
Oh,
So what's the derivative of cosine?
negative sine,
You use sine t. And what's the derivative of sine?
cosine.
Cosine t. So now you have to evaluate it. So 2 times minus sine 3 pi over 4 over 2 cosine 3 pi over 4.
Okay, so the top. Well, it'll be just negative root 2.
Yeah.
Well,
So,
negative 2 times negative root 2.
yeah, 2 times negative square root of 2 over 2. I'm sorry, this one, yeah, and then this one is negative, so it's negative square root 2 over 2. All
Yeah.
that being said, I believe it just becomes 1 here.
Because everything cancels.
Yes.
Okay.
That's your slope.
Oh, and then you use your point, your root 2 minus, or root 2 and then negative.
Y minus y1 equals slope x minus x1. So it's y minus.
Wait, does it want the normal and
I think it just wants the tangent line.
okay. So this one you just need to know your unit circle.
Yeah, it couldn't tell you which values would come up, but do you remember from your previous exam if that was something that came up?
For the previous one, I don't think we had to know our unit circle points for that one. Anything on there?
Okay. Do you want us to do one more like this?
Yeah, I think maybe one more would be good.
Okay. Let me just check that this isn't. Oh,
I have another lesson later today, so we can finish.
Yeah. So this one, it's another problem from the book. Ooh, that's not scaling well. Just another chance to put the value of t in. So x is cosine minus pi over 4. So on your unit circle, that's down here instead of being up there. If you need to grab a unit circle, I mean, it's probably good to have it out while we're working on this.
Okay, so cosine pi over 4 root 2. Well, so it'd be negative root 2 over 2.
Yes. No, cosine is positive over here. So it's root 2 over 2.
But doesn't
That's the angle. It's just that point down there. Let me grab a unit circle to clarify.
Wait, so why in the last one why was it negative?
It was 3 pi over 4, which is over here. And in that quadrant, sine is positive, but cosine is negative.
Okay.
See if I can get. Do you want us to review the unit circle at all?
Well, I'm just confused. So because it's pi over 4, it's in the first quadrant, right?
Negative pi over 4.
Yeah, but pi. Well, that's why I'm confused because
So
what do you do with the negative? Like,
well, the negative pi over 4 is down here. This is minus pi over 4. And this is positive pi.
Oh, but even though cosine, okay, I get it, because cosine is positive in the fourth quadrant.
Yes.
Got it.
Yes. Okay. So, and then we got that figured out here. Y is minus pi over 4 plus sine pi over 4. I'm sorry, sine minus pi over 4. So
So
it's,
that's where it's negative root 2.
yeah, negative square root 2 over 2. And
Wow.
even though these are bad, I mean, you're just putting them into an equation. You're not like evaluating them.
So then it's just y. Oh no, you need to do the slope, right?
Now you gotta do the slope. So now you gotta go, you know, dy dx is dy dt over dx dt. So we need to take the derivative of this. 1 plus cosine t over minus sine t.
Oh, because that's the x equals, I see.
Yes. And then you gotta evaluate again at minus pi over 4. So you got 1 plus cosine minus pi over 4 minus sine minus pi over 4.
And that's 1 plus root 2 over 2 over root negative root 2 over 2. No, positive because it's a negative.
Yeah, this is root 2 over 2 over negative root 2 over 2.
Wouldn't it be positive root 2 over 2 because it's the negative pi over?
Yes, it becomes positive. Okay, so this you could simplify, but like that's not the point here. The point is like, can you?
Is it just 1 because the pi of root 2
No,
over 2?
no. Those you'd have to divide both of them.
Oh, okay.
And this one's really messy. I mean, this is not. I mean, you're not getting center exam, but you are going to have to be able to evaluate your unit circle. You're going to have to be able to find derivatives of each.
Well, so then it would just be, then you would do like y minus,
Yeah.
I don't remember. Wait.
And so y was this minus pi over 4. It's just it's a lot of, it doesn't work out nicely, but it's correct. You know, it's not that equals your slope, which is this whole
1
thing over here.
plus, yeah.
Okay. Times x minus square root 2 over 2.
Over 2.
Now this might simplify kind of nicely, but this is, you know, you need 3 things. You need the points, and then you need the slope. And
Right.
you've successfully navigated that on this much, you know.
And then
much
if it
larger.
was like an easier equation, you would simplify that, right?
Yes, if you could, sure.
Okay.
Okay, so let's go with let's go to 53 here. Something a little more reasonable here. Is f continuous at x equals 0? Find the value of b, justify your answer. Okay. So this function is defined piecewise, and it's defined for something less than 0 and greater than 0. So for part A, you substitute x equals 0 into both. Okay. So the way that looks is it's sine ax, I'm sorry, sine a times 0 plus b cosine 0 equals 5 times 0 plus 3. So you substitute x equals 0 into both and set equal.
Okay. So
Notice that sine of 0 is always 0. So that's a unit circle thing. This is the sine of 0, which is 0. Plus b cosine 0. Cosine 0 is 1. So this is plus b equals 3.
So b equals 3.
Yes. So that's for continuous.
Okay.
For differentiable, for part B, you have to substitute into the derivative. So for part B,
Well,
you,
it says like if, what did the question say again?
justify your answer.
No, but like it says like if.
Oh, if f is differentiable.
So how do you know if it's differentiable before you do it?
Well, it's a good question. It's because you really shouldn't. It should say determine the value of
Oh, okay.
a so that the function is differentiable
Okay.
at 0, but it doesn't. So you have to take you have to find f prime of x. So
Okay.
these are constants. So give that a try first, and then I'll jump in.
It's so weird doing it without a number. Okay.
Yeah. So if you need to treat it as like a is 3 and b is 4, if you want.
So it'd be like negative cosine A. Plus B negative sine.
Sorry, derivative sine is cosine. Yeah, and then it's b negative sine x.
Just B negative sine X, right?
Yeah.
I put that down. Wasn't sure if there was something else. And then the other one too, right?
Yep. It's just 5.
5. Yeah.
So then you evaluate for x equals 0 in the derivative.
Oh, so you plug in. Okay, so it'd be like cosine A times 0 times 0 B times negative sine of 0. Is it just cosine of A, right?
Cosine of 0. Cosine of 0 is 1.
But then you also have the A.
Yeah, so this becomes a. This is b sine of 0, which is 0. So this goes away. So a equals 5.
Okay.
Okay, so part C, the way you can do part C is 2 ways. One is to actually substitute the values of those into the original,
Okay.
which is not needed, but that is the the way to do it. One way to do it.
Okay.
So you would look at, it would be like sine 5x plus 4 cosine x, and then 5x plus 3. So you would take your derivative and set them equal, and you would find that it works. Now let's just go back and briefly look here. What happened to b in the derivative when you evaluate it at 0?
It went away.
Yeah, so it doesn't matter. B can be anything. So that's another way of doing it.
Well, what do you mean B can be anything? Don't.
Well, pick a value of b. When you multiply by 0, it's always 0. So it's not part of the derivative.
But why does that matter for finding if it's differentiable?
Because you're looking at the derivative. So that's one way of looking at it.
Okay. Well, like, so do they want you to, for C, do they want you to plug it back in because it says like justify your answer?
Yeah, so that it's some combination of like putting it back in or writing a little bit of sentences there. Yeah, it's what is the back? And maybe do you have the access to the back of your book?
Yeah, I just don't know if these are in there because like sometimes the review problems aren't. Let me see.
Another thing here. Yeah, I mean The thing though is that for it to be differentiable, it also needs to be continuous. And this is not continuous at 0. We have a problem at 0.
Okay,
So actually, we don't even need to do all that. So it's not continuous because when you evaluate f of 0, you get sine 5 times 0 plus 4 cosine 0 equals 5 times 0 plus 3. This is sine of 0, which is 0. This is 4 cosine 0, which is 4. And this is 3. So these aren't even the same. So it's not continuous. So for something to be differentiable, it has to first be continuous. Continuous leads to differentiable.
okay.
All right, well, this is a good place for us to stop.
Yeah, we can pick back up at the.
Know we've got a lesson later today, so I
Okay,
will
perfect.
check in with you then.
Okay, thank you.
Thank you. Bye now.